Teach me about the Great Lakes. Teach me about the Great Lakes. Welcome back to Teach Me About the Great Lakes, a twice-monthly podcast in which I, a Great Lakes novice, ask people who are smarter and harder working than I am to teach me all about the Great Lakes. My name is Stuart Carlton, and I work with Illinois Indiana Secret, and I'm rolling solo today. That's right, I'm doing a solo podcast. We have a lot going on, and our co-host couldn't make it, but that's all right. If it works for Mark Maron, it'll work for me. And so I will just do this Mark Maron style. And so what does that involve? I'm supposed to talk about myself for a little bit, and then we'll go straight to the guest. But I don't have a lot to say, and I don't have like a fascinating early career of comedy and debauchery to talk about. And even if I did, I wouldn't talk about it with you. But I don't. So I think we'll just go straight to the guest. This is actually a cool guest. Her name is Dr. Rosalind Putland. She studies soundscapes in coastal and marine in marine and freshwater environments, and she's going to talk to us about some of her work in Lake Superior. It's kind of a cool paper that I'll put a link to in the show notes on how things go on the soundscapes in Lake Superior, and she's going to share that research with us. And I'm really excited, both because I think the research is fascinating and because she's a researcher, which means it's time for you know what. Researcher feature, a feature in which a researcher gonna teach us about the Great Lakes. Our guest today is Dr. Rosalind Putland, and she is a senior scientist at the Center for the Environment and Fisheries in the UK. But up until recently, she was a postdoc in the Great Lakes area, and that's what we're talking about today. Rosalind, how are you today?
I am great. Thank you. How are you?
I'm really good. I'm so excited to talk about this. So the name, first of all, the name is good. But the name of the paper that we want to talk about today is A Song of Ice and Vessels, Seasonal Trends in the Soundscape of the Western Arm of Lake Superior. And I think the coolest thing about this is that you actually completed it, which with that naming scheme, maybe you wouldn't complete, but you did. So this is about soundscape ecology, right? What is soundscape ecology exactly?
It's a great question. A lot of people don't know what a soundscape is. You know what a landscape is, right? You're around us every day. We go outside and there's birds and trees and rivers if you're in a really nice house somewhere in the middle of the woods, or there's roads with cars and things like that. So when we're talking about the soundscape, we're talking about the sounds that are emitted by all of those things that you see around you, except just close your eyes and what are you listening to? So that's the soundscape. I have been working in this for the last 10 years and in a variety of different habitats. So whether it's marine, and then luckily this latest paper of mine is on a freshwater environment, which is so exciting. And I'm really looking forward to chatting to you about it today.
Yeah, great. So soundscapes are the different sounds that are out there, right? As we walk around, sometimes natural, sometimes not. Like right now, if I close my ears, I can hear an air conditioning. That's part of my current soundscape. It's a really crappy window unit. So if you see me start to sweat, it's not your fault, it's mine. But what is the ecology part? So we know what the soundscape is. What kind of things do you study, I guess, with the ecology part of it generally, and then we can move into this paper specifically?
Yeah, so the ecological side of it comes from kind of the interaction of sounds with how we behave, or the animals that I study, how they behave. So if you went back 1,000 years ago, animals would have only been listening to each other, to the sound of wind and waves or rain, as well as their similar species or even predators and prey. But now we're also looking at the kind of interface with humans. So what are we creating? What sounds are we getting in the environment? So whether that be in a terrestrial system, cars, planes, or in the aquatic environment, vessels, ice augers, fishing vessels, anything like that.
So all these things in the I guess terrestrial environment and the aquatic one are now part of the soundscape, and it has changed. Huh. I guess the different components then, and you talk about this, you have some fancy words, right? And so the words you use for your components, if I remember, and Lord knows I'll probably not pronounce these right, but so we have geophony. Is it phony or phony? Phony? Biophony.
Doesn't matter either way.
Okay. Anthropophony. Those are the components you talk about. Let's talk about those kind of one at a time to understand what they are and how they might contribute. So the first one you talk about is geophony. Tell me about that.
Yeah, so geophony, you break it down, all of these. Phony basically means sound. So geo is geological, predominantly activity. So kind of natural sounds, but nothing to do with animals. So in a soundscape, those are mainly formed of weather, whether it be rain, wind, ice movements as well. And then geological activity, so things like earthquakes. And we can record earthquakes from many miles away and actually pick them up through vibrations in the land, but then that can dissipate into the air or the water environment as well.
Okay, that makes sense. It's a lot of weather, a lot of earth. Does the earth have I guess the earth has some sort of base level of noise, right, that it makes?
Yeah, when it's rumbling and all those tectonic plates moving around out in the big ocean.
Can you hear that? Tectonic plates, do they make sounds that we can hear? I mean, outside of earthquakes, I guess?
I guess it's only really when the big earthquakes happen that we pick it up as sound.
Or at least on our time. Who knows what's happening on geologic timescales, right? Maybe there's stuff
exactly.
Okay. Biophony. So I can do this one. Bio means having to do with life, right? And so biophony is the different sounds that animals make. Is that right? Is that like vocalizations, or is it, if a fish or an animal runs through the forest, maybe, would that count as biophony as well?
I guess so, but we as scientists are maybe interested in their vocalizations. But some animals can make kind of passive sounds as well. So they're not necessarily known for it. You talk about fish actually wiggling, and it's kind of like that. So some fish have like bony structures on their fins, and if they rub those against the rocks, that'll produce a sound. But that's thought to be an active, they're deciding to make that sound. They're not just, when they're moving along.
So here you're more interested in the ones they actively choose, and different fish drums make noises, or what's the fish that, oh my God, I even picked it in our draft. The fish that makes all the sound while it's reproducing. Burbot?
Burbot, yeah, yes. There's burbot, the only freshwater cod species. And then some of the fish that most people will be familiar with, because they sound like onomatopoeia, what they're called basically is what they sound like. So drums, grunts, and exactly right. They sound like that.
Okay. And then anthropophony, which you consider separate from biophony, just I think because it's easier to classify it that way, I assume, even though people are alive. But anthropophony, that's human-based noise. And so that tends to be like we consider machines and things like that. Is that right?
Yeah, so things from human activity, which, it doesn't necessarily have a negative connotation. I think more so now, people think of like the effects of noise produced by people. But yeah, vessel activity, planes, people walking on ice when lakes freeze over, all of that produces sound in an environment. Sure.
And as you said earlier, these are sounds that are relatively new, right? Since, I don't know, the Industrial Revolution or whatever, certainly in the last 1,000 years.
Exactly. Yeah. So we can track it back that when Industrial Revolution happened, suddenly sound became a thing.
Yeah. Suddenly we started exerting ourselves, orally speaking, I suppose. Yeah.
Exactly.
Yeah. So this has been studied in marine systems more than lake systems. And so I guess my question is so what is the soundscape like so you studied, I can't remember, it was Lake Superior, it's the western arm, right? And so in Lake Superior, if you had to characterize the soundscape, how would you characterize it?
Well, actually, Lake Superior is pretty quiet in the grand scheme of things. So what I was listening to was kind of in the western arms, close to Duluth and Superior, which are the two of the major ports in the Great Lake. And so there was a lot of vessel activity during the summer months, right? When there's commercial vessels transiting along the coastline for various activities. But then during the winter months, Duluth is one of these cool ports that actually closes because of the ice cover. Oh, and right. During the time when I was recording, it was 100% ice cover at certain times. And so it was shut down for almost, I think it was 6 weeks, 8 weeks. And so that meant you suddenly removed that kind of component of anthropogenic activity. And that was super cool to see, because what were we then able to hear? And, we started to pick up potentially some biological sounds, maybe from different species of fish. And then you could hear, ice movement. And it's this super eerie, cool sound that, I think of it as like a Star Wars sound to me, where you can hear like the ice cracking and crunching and moving on the surface of the water.
Whoa. One thing you said is that all of a sudden you start to hear more fish species, right? Is that because they weren't making noise before, or that they were harder to hear with all the ship traffic and everything?
That is a question that I honestly don't know the answer to, because, when you have human activity, it's very loud in the environment. And so it has this kind of activity called masking. It's what we generally term it as, where you can't hear maybe what could be going on at the same frequency because it's much quieter. So it's also sometimes called like the room effect. You know, when you go to a party and lots of people are talking at once and you can't hear the person talking next to you.
Yeah.
It's kind of the same concept in a soundscape, that, you know, one fish might not be able to hear another one because of all the activity going on around. So during the summer months, these fish could be making sound and we just weren't able to pick it up at that time. But then during the winter, we were suddenly able to hear all these fish, and it's kind of, they're almost got their own niche in the environment. And you know, when it's quiet, let's all talk to each other, and then when it's loud, they might stop. But that, as I say, is a question that is going to be for future work.
Sure. So we don't know, but so it's, I mean, you don't want to catastrophize, right? And it has been like, you know, but you could see that potentially that the sounds could really be disruptive then if the animals can't find each other, especially because I'm not a limnologist, but I would imagine when you get the ice cover, things get pretty dark in the lake. And I would think that sound becomes relatively more important, right? And so if they can't hear each other because of masking or because they shut up to listen to the ships roll, I guess that could be bad, huh?
Yeah, and that's what various managers for different organizations are looking into, because this is now like the new pollutant of the environment is noise pollution. And so, you know, it's now coming into legislation in various countries that we have to control how much noise is produced by different types of vessels. There could be things like speed reductions put in place in certain busy areas, because the slower a vessel is, actually the quieter it is normally. And so, you know, slowing down traffic in particular environments where there's species that we're interested in could be beneficial.
Oh, geez.
Yeah. But it's a positive thing. We are looking at the levels of noise in various areas, and, you know, hopefully it means there's going to be more environmental management in the future.
Yeah, I hadn't thought about it, I mean, until now, but as a form of pollution. So the other kind of weirdo form of pollution that you didn't learn about necessarily when you were a kid, well, I didn't learn about when I was a kid, was light pollution, right? And so they developed this thing, I think it's called, well, I know it's called because I just looked it up, it's called the Bortle scale. And like they have these maps and everything. Is there a similar scale for sound pollution, or is it kind of too nascent for that to be the case?
It's very early days in terms of management for that. You know, the more that we share different scientists in different countries, then hopefully over time that'll be a thing that we can map sound in various areas. That's something I'm involved with my current job. Is I map sound in the North Sea and around Europe with other countries, and we're kind of looking at that management system.
Right.
Lake Superior and the Great Lakes, is very little has been done in terms of sound. You know, this is one of the first papers that's been published on sound, as well as my colleagues who've worked on it in the past, and you sort of hope that maybe in the future more people are going to be interested in sounds in the Great Lakes.
I mean, it's such a small field. I would assume that it's you got to find a couple of good researchers who are interested in that.
Yeah, and like soundscape ecology is not easy, because as many of the listeners will know, like if you live around the Great Lakes or even small lakes in Minnesota, Wisconsin, Michigan, they freeze for half of the year, and so suddenly, like, the ways you normally put equipment out become not possible.
Oh yeah. Well, let's talk about that for a second, and then I'm going to compare the freshwater to the marine. But so how do you measure this? I'm envisioning, well, actually what I was originally envisioning was a graduate student with like a stick and a microphone on the end of the stick, and they have to sit there for like like certain amount of time. But I'm guessing that's not how you actually do it.
That's how it was done old school back in the day. Somebody would go out with headphones and stick a microphone underwater and listen to the sounds. Now, not so much. It tends to be very autonomous. So we actually put, it's called a hydrophone, an underwater microphone, and it's all like a remote unit, and we deploy it on a very, very large weight at the bottom of Lake Superior. So it was about 5 meters above the lake bottom. And it had an acoustic release on it, as well as a load of other equipment. So basically the vessel then goes back out a couple months later and sends it a ping, and it pops out some buoys and floats to the surface. And then you pick it up with a vessel. Because obviously you can't have anything on the surface, A, because you don't necessarily want people to know that you got expensive equipment underwater. But B, when the ice comes, it would all just completely tear it all up. So it has to kind of be right underneath the ice.
And so some of these, yeah, that's right. But some of these you left out for the entire ice piece. You must have had external battery packs or something like that.
Yeah, they can last several months recording. I wasn't recording continuously. I was kind of recording for a little snippet every 10 minutes just to kind of give you a little piece of information about what's going on. And then we went back once the ice had all cleared up and we could get back on a boat and go out and pick up our equipment, and hopefully it returns to the surface, which it did. It's always a danger losing equipment when you work in the aquatic environment. But yeah, it was all there and it was all good.
That's good. I'm glad they're still there. And what a cool way to just submerge those in. But then you do kind of hopefully had some telemetry or something so you could find them if not. But so we have these data buoys in Lake Michigan. They're most famous things we do at Seagrant are probably those data buoys. This podcast accepted. Could we put recorders on the bottom of the data buoys? Would that be something? Because they're out for 4 or 5 months a year, never during the winter because of the ice. But would that be, I wonder if that's something we could do.
This is something that's been talked about with actually collaborators I've worked with, and they've said, you can put things from the surface. The only thing you are going to pick up a lot of is any surface movement.
Oh yeah,
because
these are very high.
That happens if they kind of go up and down, you're going to get a lot of bobbing motions, which you kind of have to live with what you can get. And if you can get out, the boat's going out to put that out, then great.
Yeah, that's interesting because we have these temperature strings on them that measure temperature at depth every, X number. I don't know. This isn't my deal. I'm a social scientist, but I wonder if we could, duct tape one to, interesting. Well, I'm sure our partners at GLOS, the Great Lakes Observing System, are I'm sure, and Limnotech, I'm sure they're thinking about this harder than I am. But that's cool. But so I guess then the depth you set them at makes a difference, right? So up near the surface, you're going to get any waves. I bet you could get rainstorms and things like that.
Exactly.
Yeah. Is 5 meters, is that just kind of something you picked, or is it I guess we don't know. So you're sort of limited in your worldview or your world sound, I suppose, in terms of what depth you chose. But fish maybe, or other animals maybe at different levels, right? Are there implications to that, or is that just kind of how it is?
Yeah, I mean, in the past, I've always put close to, my recorders close to the bottom just to pick up any fish sounds, really.
Yeah, sure.
Because, you're kind of assuming there's going to be a lot of activity around the lake bottom, protected area, all of that. But there'll definitely be differences through the water column. And other folks, so Jay Austin, who's one of the co-authors on the paper that I published, they've looked at acoustic levels through, and hopefully that's going to be something that they'll be publishing in a few years' time, or in the coming months even.
That sounds good. All right. Well, I forgot. So we found out about the winter ice in a little bit, but I realized I haven't even asked you for the main deal in your paper, which is looking at seasonal trends, right? And so I think broadly what I would expect is right during the peak boating season, which is probably going to be summer, right? Because you get more recreational boating and you get whatever commercial stuff is happening in there. You're going to be hearing a lot of boat sounds, right? And then if you can pick up weather that deep beyond ice? Maybe you'll hear rain and stuff like that. And then maybe that'll change as the winter comes in. But is that right? Or what is sort of the general trends that you found in your paper?
You described it very well, actually, the seasonal trends, the paper. The Great Lakes is a super cool ecosystem. The fact that you have such stark differences between winter and summer. So it's a fantastic ecosystem to work in because you get that 100% ice cover potentially happening every winter, port closures. And so you're kind of picking up, an environment without anthropogenic activity, which was really cool. But in terms of seasonal trends, yes, there is vessel activity heightened in the middle of the summer months, and during sort of spring and the fall, we could pick up some weather activity. And I kind of, during my paper, I had a nice plot that kind of showed some of the types of activity that we picked up sort of week by week. And you can see that during the kind of spring and fall, you get a real mixture of everything. Whereas during the height of the winter, it's mainly ice, almost 100% ice sounds. And then during the peak of summer, it's mainly 100% vessels.
Yeah, that's cool. But I think having a record of that is really important, right? A lot of times what I say about science is a lot of science is sort of the art of proving the obvious, right? Because you need to establish that base before you can then do the next round of things. And so that's really, really critical. All right, a couple more questions that I think are important. What is the coolest thing that you heard? So wait, do you go through and do you actually listen to all this, or do you do some sort of automated analysis, using, I don't even know, waveform visualizations or something?
So when we had the recording equipment out there. It was out for like a year and a half almost.
You can't listen to all that. Yeah.
So I can't listen to all of that. I would be here listening to sound for the next 10 years, basically. And so I actually listen to full moon and new moon recordings. A lot of people ask me why I do that. And that's because
that was my next question. Yeah.
The light levels, are at their peak during the new moon, and then the lowest during the full moon. And there's been a lot of studies showing that fish actually will vocalize more or less depending on lunar activity.
No
So
way.
when it's brighter in the environment, they may be quieter because they don't want to make themselves heard. But then other species actually don't want to vocalize when it's dark because they don't want to give away where they are. So I kind of chose these two. It's nice to pick those based on the lunar calendar. And it means that I'm not having to use like a random day calculator to choose what days of the month I choose.
That's unbelievable. That I didn't realize that it was that the moon had that big of an effect, even far down in Lake Superior. That's just stunning to me. That's amazing that fish and presumably other animals are that responsive to the phase of the moon.
Definitely in the top few meters at least. And then there are a lot of fish species that will kind of migrate up and down the water column during the day and the night period. So yeah, it's nice to have some sort of link to potential biological activity when you choose your random days to listen to.
That's really cool. Is there that same trend in marine as well? Do you know? Being same lunar trend in marine animal vocalization?
Yeah, so that's where it's been found particularly around reefs, so both rocky reefs and coral reef areas. This is a very significant trend, and so that's a lot of what I was basing my paper off. I was going to do the same thing in a freshwater environment as they've found for many, many years in the marine.
And you found the same thing in the freshwater then. That's really cool.
I wouldn't say, because I didn't have a huge number of fish sounds, and because I didn't have cameras, I can't identify what fish I was particularly listening to. I'm assuming it's fish. In the paper, I actually just refer to it as biological sounds because I can't make the assumption, even though there's not a lot of other vocalizing animals in the lakes. When you're working in a marine environment, you could turn around and say, well, it might be a marine mammal or it might be a certain type of invertebrate. But here, we're mainly thinking it's probably going to be one of those fish species.
Yeah. Wow, that's really cool. All right, so when you're listening, so here's my question: did you hear anything like really cool or unusual? Ideally you would have heard like some sort of sea monster or lake monster that was never been found before. You obviously wouldn't tell us about that though, because the government would be. So that's fine. I don't expect you to tell us about that. But south of that, was there anything really kind of cool that you heard?
I think honestly the ice sounds were the coolest things I heard. I've also recorded in small lake environments, and I think the sound of people walking on ice is actually pretty cool. Some people think that's a bit like, what? Hearing the crunching sound a couple meters below the surface is interesting to think, okay, well, whatever's living underneath actually can hear me walking along too.
Well, this is really fascinating work, and I'm newly obsessed with so there's a guy, Brian Pijanowski is his name, and he does soundscape ecology at Purdue, and they've got an app and everything for some community science. And so I've heard Brian speak about it, and he's got fancy microphones too. But I hadn't really given it much thought until I saw this paper, which is so relevant. And this is just, I am newly obsessed with underwater sounds in the Great Lakes. And so I really thank you for coming on to talk to us about that. But that's actually not why we invited you here on Teach Me About the Great Lakes this week. The reason that we invited you, on Teach Me About the Great Lakes is to answer two questions. The first one is this: if you could choose to have a great donut for breakfast or a great sandwich for lunch, which would you choose?
As a British person, I have to say a great sandwich for lunch because I'm not a huge donut fan, unfortunately.
Are there not, I don't know, are there not donuts in the UK or what's the deal with that?
They're when you go to a beach, maybe you might get them from like a local stand. But yeah, can't say I'm a huge donut person. I want to try the cronuts though. They sound good. The croissants.
I mean, they sound good in a certain kind of way, right? You can't try too many cronuts, right? There's a life limit on cronuts. I haven't had one either. Even I have limits. Okay, but so you were at the University of Minnesota, right? Were you up in Duluth?
Yes, I was at the University of Minnesota, Duluth. Yeah.
So when I go to Duluth to visit my Minnesota Sea Grant colleagues, I'm going to go out to lunch and I'm going to get a sandwich. Where in Duluth should I go to get a great sandwich?
I would definitely recommend going to the Duluth Grill, not only for the food, but also for the carrot cake. That is amazing.
Now, this is not part of the question. However, I completely agree. I'm going to go look at a picture of this carrot cake. Okay, great. And so the other thing we're trying to do is, part of the reason for this podcast is we want to encourage people to think of to recognize what a amazing resource the Great Lakes are, both the scientific, biological, it's all the fresh water, but also a cultural resource. And so we like to ask our guests, if there's like a special place in the Great Lakes to them, or a place that they'd like to share with our audience, and maybe what makes it special.
For me, being in Duluth and living there for almost 3 years, I used to just love walking along the coastline of Lake Superior, just down in Canal Park, or hiking along the coast. It's a lovely place to be.
That's wonderful. I thought you were going to say 5 meters from the bottom of Lake Superior.
I wish I could have gone that deep down. Also a little bit cold for me too.
A little bit cold. Yeah. What is this? So you're 5 meters from bottom. I didn't ask. And then anyway, what is the depth there total in the area where you were? Was it like 50 meters? I don't even know what the depth is. Yeah.
Yeah, it was around 50 meters.
Look at that. I don't know why I guessed that. I just did. Well, this is really fascinating work, like I said, and I encourage everybody to go check out the paper, read it. We'll have links to it on our show notes at teachmeaboutthegreatlakes.com/60, the number 60, because this is somehow episode 60. But if people want to find out more about sort of these lakes observing, or maybe the work that you did, now that you're in the UK, it's probably somewhere different, but is there a good resource for people to go to?
I would suggest people check out the University of Minnesota Duluth Biology Department page, as well as the Large Lakes Observatory.
Great. And look for those links in the show notes. And for now, Dr. Rosalind Putland, a senior scientist at the Center for Environment and Fisheries in the UK and former postdoc at the University of Minnesota. Thank you so much for coming on and teaching us all about the Great Lakes.
Thank you.
Again, a fascinating interview on some really interesting work and soundscapes. Cool stuff, right? And another form of pollution, which is a little bit depressing. It's amazing the sort of just effect that we have on the environment all over, intentional and unintentional. Hey everybody, this is Stuart, and I'm checking the box, Jason, because we have a breaking bit of information here, and that is that Rosalind last night, after we recorded, was able to send me in 2 sounds from her actual recording device. I should have asked if she named them. She should have named them. But anyway, she sent me sounds from her recording device, and so I've got 2 of those here, and so we're going to get a chance to play them. And so I think that'll be cool to play them and listen to them. So this is what things sound like underwater. And the first sound is called Example Fish Sound Unidentified 1. So let's take a listen. Wow, that's really rhythmic in the way that is. And you can hear the... That's really, really cool. But then, so that's the biophony, right? But if you hear in the background, I don't know if that's just noise in the microphone, but it does sound underwater, right? So you can probably hear some geophony in there too. Let's listen to that one more time. That was really cool. Wow, that's neat. Okay, and then the second sound she sent is just called boat. So I'm assuming that's some sort of a boat. Let's check that out too. Whoa, okay. So you can really hear it. There must be a boat passing by the microphone, right? You can hear it getting closer and getting louder and then fading off into the distance. Let's hear that one more time. Hey, that's cool stuff. That one actually reminds me of, let me see if I can find the sound effect. Right here. That reminds me of the THX sound, when you go to the movie theater, or I don't know if they still have those in the movie theaters, because I'm pretty sure the last movie I saw in a theater was The Social Network, which would have been like 2010 or so, because I'm old and I have kids and, life is busy. But that sounds a lot like they at least used to play this sound in the theater a lot, the THX sound. So let's check that out now. So maybe the fish can get their own movie theater together and just time it with the boats going by to test out their sound system. Anyway, that's neat stuff. It really does go to show you, the amount of sound that we are creating potentially underwater with that boat stuff. And you can see why it might be disruptive. And it'll be interesting, potentially sad, interesting to hear how those studies, as people continue to study this and study the effects, is it something that, over a period of 100 years or more might start to have an effect on fish distributions or populations, or it might, create a new artificial or a new selective pressure or whatever. I'm not sure. Well, shoot, since we're here playing sounds of boats, we might as well go with our favorite boat sound, of course, from our friend Captain Dean on the research vessel, the Guardian, which is being repaired right now. So it's not out this spring. The poor Guardian, it's been a bit thanks to COVID since it's done a lot. But we'll hear from the Guardian right now too. What the heck? Thanks to Captain Dean for that one. And thanks to you for listening. Now, like I said, I'm recording this the next day, so I don't remember exactly where we are, where we're going to insert this. But we'll just put it in right now. End of the breaking news segment. Thanks a lot, and enjoy what remains of the show. That's going to do it for this week's show. Thank you so much for tuning in. If this were like a Mark Maron, this is the point at which he chimes in with some guitar playing, I guess, because, he plays guitar. But to me, it's well, who would be so egotistical and arrogant to be well, now I'm going to use this time to show my guitar skills. It's what does that even do? It doesn't even really belong in the thing exactly. So I don't know exactly who would do that, but it's not something that I could really see myself doing. Teach Me About the Great Lakes is brought to you by the fine people at Illinois Indiana Sea Grant, and we encourage you to check out the great work that we do at iiseagrant.org and at ILINC Grant on Facebook, Twitter, and other social media. Teach Me About the Great Lakes is produced by Hope Charters, Carolyn Foley, Megan Gunn, Irene Miles, Ethan Chitty. He's our associate producer and our fixer. Our super fun podcast artwork is by Joel Davenport. The show is edited by the awesome Quinn Rose, and I encourage you to check out her work at aspiringrobot.com. If you have a question or comment about the show, send us an email, teachmeaboutthegreatlakes@gmail.com, or leave a message on our hotline, 765-496-IISG. And you can also follow the show on Twitter at Teach Great Lakes. Hey, thank you so much for listening, everybody. And as always, keep grading those lakes.